into the ground. Often using a pile driver, this casing, which has a diameter of approximately 30 inches or 750 millimeters, is hammered into the ground to a depth of around 100 feet or 30 meters. This section of casing prevents unconsolidated surface formations from collapsing while drilling deeper. To drill the surface section of the well, a drill bit with a smaller diameter than the inside diameter of the conductor casing is used. A 26-inch or 650 millimeter diameter drill bit is about the size that is used. The well is drilled through the unconsolidated formations to a depth of about 3,000 feet or 900 meters. The precise depth will be determined by the rock types and formation pressures. Then, the drill string is pulled out of the hole, and a string of surface casing is lowered into the hole, joint by joint, until it reaches the bottom. The surface casing has a diameter of about 20 inches, or 500 millimeters. Cement slurry is then pumped down inside of the casing, through the bottom of the casing, and into the annular space between the casing and the borehole. Drilling mud is used to push the cement down inside of the casing and back up the annulus. When hardened, this cement sheath acts as a seal between the casing and the borehole, preventing cavings from falling down through the annular space between the casing and the hole. The cement also keeps the cavings out of the next hole as it is drilled, and it keeps fluids from the next hole from coming up into the annular space. Once the cement has set, a large flanged bowl, called a wellhead housing, is attached to the top of the surface casing. The wellhead housing is used to support the casing strings, provide a seal between the casing strings at the surface, and to provide access to the annulus between the casing strings at the surface. Before drilling the next section of hole, the blowout prevention stack must be installed. A blowout occurs when high-pressure formation fluids enter the well bore and flow up to the surface. If uncontrolled, the fluids can cause equipment damage and jeopardize the lives of the crew. A blowout prevention stack, or BOP stack, contains valves that close around the drill pipe, sealing the annular space between the drill pipe and the casing. The next section of hole is now ready to be drilled, using a drill bit of approximately 17.5 inches, or 440 millimeters diameter. Once a 17.5-inch hole has been drilled, the drill string is pulled, and the intermediate casing is run and cemented in place. The intermediate casing has a diameter of about 13 3/8 inches, or 330 millimeters. The casing is supported by the rig while it is cemented into place. When the cement has hardened, the BOP stack is removed, and a wellhead spool is mounted on top of the wellhead housing. The wellhead spool supports the weight of the next string of casing and the BOP stack. With the BOP reinstalled, the final section of hole is drilled into the production zone. For this hole, a bit of about 12.25 inches or 300 millimeters diameter is used. While this section is being drilled, the cuttings brought to the surface by the drilling mud should show evidence of hydrocarbons. After drilling, the drill string is pulled out, and tools and techniques are employed to verify that it will be economical to complete and produce the well. In some cases, it may be desirable to retrieve a large cylindrical sample of the reservoir rock, known as a core. In order to do this, the conventional bit must be pulled from the borehole when the conventional drill bit is about to enter the oil-bearing formation. A donut-shaped bit is then attached to a special large-diameter pipe, known as a core barrel, and run into the hole. This coring assembly allows the core to be cut from the rock and retrieved. Porosity and permeability measurements can be conducted on this core sample in the laboratory. Another way of evaluating the production zone involves inserting special tools into the well to take measurements. The tools, called logging tools, are run into the well on conductive cable called electric wireline. Wireline logging tools can measure properties such as the electrical resistance of the fluids in the rock to determine whether the rock contains oil or water, the bulk density of the rock to determine the porosity of the rock, and the natural radioactive emissions from the rock to determine if the rock is clay or sandstone. Measurements are transmitted along the wireline and plotted at the surface. In some cases, tools will be run in the hole which will allow the hydrocarbons in the producing formation to flow to the surface in a controlled manner. At the surface, tests can be performed on the hydrocarbons. Since the produced fluid is allowed to flow through the drill string, which is also known as a drill stem, this test is called a drill stem test, or DST. If the evaluation of the producing formation indicates that a substantial amount of hydrocarbons are present, the oil company will decide to complete the well. Otherwise, the well will be abandoned. The first step in completing the well is to run the production casing across the oil-producing zone. In this case, the production casing has an outside diameter of around 9 5/8 inches, or 240 millimeters. To initiate production, explosive charges are run down the tubing on wireline and positioned adjacent to the pay zone. In a process known as perforating, the charges are detonated, shooting holes through the casing and cement into the formation. After the production casing is perforated, a string of pipe, known as tubing, is run inside the production casing string. The tubing typically has an outside diameter of 4.5 inches, or 110 millimeters. The tubing carries the formation fluids up to the surface during production. The annulus between the production casing and the production tubing is sealed off by a device known as a packer. This device is run on the bottom of the tubing and is set in place by hydraulic pressure or mechanical manipulation of the tubing string. Next, the BOP stack is removed and a set of valves known as a Christmas tree is installed on top of the wellhead. The Christmas tree is used to control the flow of oil once it reaches the surface. The hydrocarbons flow into the well bore and up the tubing to the surface. The well construction process has come to an end and production has begun. Now that you have completed this module, you should be able to describe the drilling, casing, cementing, and completion processes. Describe the tools and techniques used to drill deviated wells. We also learned about various directional drilling tools, including navigation subs, mud motors, and MWD. We also learned about the step-by-step construction of a well, including drilling the hole, installing the different types of casing, and evaluating the well. Finally, we described the processes required to complete and produce the well, including running production casing, perforating, and running a tubing string. If you are still unclear on any of the objectives, now would be a good time to go back and review.